Okay, here we go. Now we finished the first page. Anybody listening to this recording, here's the work that, I'm just talking to these guys, if you're, not you guys. Here's the work from this problem that got cut off. Adrian, quit talking. The work is right here. I follow this all the way down to the bottom. There we go. Cotangent does equal cotangent, so we did prove it. Okay, period 6, let's continue. Okay, now, you are now here. Set page 2, right? Page 2 talks about new identities. What are these identities? They're called what? Pythagorean identities. Okay, I'm going to tell you the first one, and I'll prove the first one. The second one and the third one, might prove this one. Don't think I'll prove that one, okay? So here's what they're telling you, straight out. They tell you this. Cosine squared plus sine squared equals 1. They just tell you that's the Pythagorean identity. Then all of a sudden they tell you this one. 1 plus tangent squared equals secant squared. Then they tell you this one. 1 plus cotangent squared equals cosecant squared. Okay, that means nothing to you unless you actually know why. So watch this. You might want to draw the picture up above. Here we go. Where did they get the first one from? Here's where they got it. Remember, x is now called cosine of theta. Y is now called sine of theta. The unit circle, the radius is 1. Okay? There's your circle. So this is called the Pythagorean identity because they took it right off the Pythagorean theorem. The Pythagorean theorem says if you take your leg, square it, plus your other leg, square it, it should equal what?
The last leg squared.
Well, no. The hypotenuse squared. Okay, so let's square your first leg. Well, cosine of theta is your first leg. Square it plus your second leg. Sine of theta, square it. It should equal your hypotenuse squared. What's your hypotenuse?
That's
1 squared. But 1 squared is 1. So I'm not going to write the square part. So this is where they got it. They just looked at your triangle that you always deal with day after day, and they said, wait a second, there's an identity here. It's right here. Cosine squared plus sine squared equals 1. Okay, then they came up with 2 more. Now this is weird how they did this. It's kind of cool though. What they did is they said, well, in any equation you can do whatever you do to the left side, do it to the right side. And you don't change it. So what they decided to do is this. They said, well, let's just take this side, this left side, divide everything by cosine squared. And then whatever you do to the left side, you got to do what? To the right side. And then what happened is this. Cosine squared divided by itself, cosine squared is what?
Nothing cancels.
Well, yeah, it's something. It's 1. It does cancel, but it's 1 over 1. Plus sine over cosine is what? What?
Tangent.
It's tangent. Sine squared over cosine squared is tangent squared. 1 over cosine becomes, it's a reciprocal function, secant. Yep, this is secant squared. Okay, so this is the next Pythagorean identity. You need to recognize it. Because if you recognize it, you can change things. Okay, now I'm not going to prove the third one, but in the third one, you know what they did? They
just
did
the reciprocal.
No, the third one, they did this. They divided everything by sine squared instead of cosine squared. So if you divide everything by sine squared, what do you get now? What's cosine over sine? Look at your front page. Cotangent. Yep, that's cotangent squared, right? Okay. What's sine squared over sine squared? There's your 1. And then, of course, what's 1 over sine squared? It's the reciprocal. Cosecant squared. Okay, so this is how they got the other two. They took the original one, cosine squared plus sine squared equals 1, just divided. They picked cosine at first, and then they picked sine second. Then they got these two. These are Pythagorean identities. Now, how do you recognize them? How do you know when you have one?
You just look at the different equations.
Well, you got to look at it and say, I have two trig functions that are both what?
Equal or square.
They're both squared. And I have what number? A 1. Look, two trig functions, both of them are squared, and I have a 1. Two trig functions, both of them squared, and I have a 1. This is a Pythagorean look. You need to know when the look is there and recognize it. Okay? All right, so now let's keep going. See that number? Number 9? What does secant squared minus 1 equal? Look at your Pythagoreans up top. There's 3 of them. Doesn't this one with secant look like this one? What does it equal? Tangent squared. How'd you get that?
I just looked.
You just look. But how'd you do it?
Well, if you look at the equation,
Secant squared minus 1. Wouldn't you guys just move the 1 over here with secant? How? Minus 1. Minus 1. Those are gone. What does secant squared minus 1 equal? Tangent squared. You have to manipulate these formulas to make them work for you. Yes, this minus 1 is tangent squared. Just manipulate it a little bit. Minus 1, or do whatever you got to do. So what's cosecant squared minus cotangent squared equal to? I'd be looking over here. Did you say 1?
1.
Okay. Here's cosecant squared, here's cosecant squared, minus cotangent. That means they moved it over, guys. Minus cotangent squared. Minus cotangent squared equals what?
1.
It's 1. So when they start doing that to you, you change the formula to make it work for you, okay? And you will see what I'm talking about in just a little bit. Okay, this is where it repeats a little bit from the first page. Take cosecant times tangent, and look what they don't do for you. They don't tell you what it equals. So now they're not giving you the answer. Now they're saying, just take those two functions, multiply them, and come up with an answer. Go. This is exactly what you did on page 1. This is why you get better right now, because you know what you're doing. Somewhat.
Somewhat.
Yeah, not 100%. Somewhat. Cosecant, bad. Tangent, bad. What are we trying to make them?
good.
Well, what's good?
1 over sine of theta.
Well, I was hoping you said make them sine and cosine.
Oh.
So what is cosecant? You 1 over sine. There you go. Just change them, guys. Okay. And tangent, I don't like tangent. I want sine and cosine. So what is tangent?
Those are 3 values of tangent that goes on the sheet.
This means just sine and cosine.
You don't listen. You don't want to do the reciprocal one because if you did the reciprocal one, you'd write 1 over cotangent. I don't like cotangent. Yeah, you want to do the one that has sine and cosine in it. So tangent's what? Sine over cosine. Hey, how come I can't use the Pythagorean on these? Well, there's no
It's not
square.
square.
You gotta have a square to work with Pythagorean. Okay, so guys, there's your problem right there. I think you can do it. Multiply the two fractions. Cancel what? Sine once, sine once. Answer on top, 1. Answer on the bottom, cosine. I don't like fraction answers. Don't tell me the answer is 1 over cosine. Give me a nice simple function.
Secant of theta.
It's just secant. That's a reciprocal secant. So you just say, hey, all of that multiplied is just secant of theta. This times this is that. The answer is secant. It's exactly what I did in the first page. I'm just repeating what I did in the first page. Go and do the next one. You won't get better unless you try. And some of you right now, you're not writing much down, I can tell. You don't even have a pencil in your hand. Is that what you did? Did you turn secant into 1 over cosine? And did you look at cotangent and say cosine over sine? Okay. If you did that, it's just multiplication. What cancels?
Cosine of theta.
With cosine of theta, 1 over 1. Answer on top. 1. Answer on the bottom.
Sine of theta.
Sine of theta. Looks like that's the answer, but you can clean that up a little bit. Call it what?
Cosecant of theta.
Cosecant. Whoops, sorry, I messed that up. Cosecant is C. Okay. Cosecant of theta is the answer. Got it. Good. Yeah. All you have to do is tell me what that times that is. So secant of theta times cotangent of theta is the same thing as cosecant of theta. You're just cleaning up the mess. There's a mess on the paper, cleaning up. All right, here's another mess. Okay, this is my question to you. Remember when I said the Pythagorean identities have cosine squares in them and tangent squares? Does this look like a Pythagorean
No,
identity? Why not?
because it doesn't have 2 squares.
It doesn't have 2 functions squared, but it doesn't have to have two functions squared. It has to have also the number what?
1.
You gotta have a 1 in there, or a trig function squared. Well, I have the trig function squared. I just don't have the 1, or I don't have the other Pythagorean. Plus, this is all multiply, by the way. If you look up there, Pythagorean is addition. This is just clean up the mess. Get rid of all that junk and put sine and cosine on paper. Do you like cosine squared?
Yep.
It's cosine. You should like it, but you know what you guys might not like?
Squared.
What is cosine squared? What does that mean?
Cosine.
Yeah, it's cosine times cosine. Maybe you want to write that. Cosine of theta times cosine of theta. Maybe that makes more sense to you. I don't know. You don't have to do that. Next would be times secant. What's that? 1 over cosine of theta. Good. Times, see, cosecant. 1 over what?
Sine.
Sine. Okay. All right. It's multiply, 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 multiply. 4 numbers multiply. Looking to do what first, though? Probably cancel a couple things out, right? 1, 1.
You can also cancel out the, no, never mind.
What?
No,
Okay, nothing? Oh, did you want me to cancel both of them? Is that what you were thinking? Because I only have 1 cosine on the bottom. I can't do both up top.
no.
So what do you get on top?
I was thinking for something else.
On top, multiply. What do you get?
Cosine.
Cosine. On the bottom, what do you get?
Sine.
Sine. So your answer becomes
Cotangent of theta.
cosine of theta over sine of theta, but otherwise known as cotangent. That's cotangent, guys. You're looking at cotangent. Boom. This times this times this is just cotangent. Did it. All done. Okay, next. Oh, here we go. All right. Now look at this one. What do you think? What do you want to do?
Zip
Get rid of cotangent.
What do you mean by get rid of cotangent?
Switch it to sine and cosine.
Okay.
Can't they cancel?
Can they cancel? Here's the deal. I wanted somebody to say that, and finally Molly said it. The answer is no, Molly. Here's why. Molly, I wanted somebody to say it, and I knew you'd say it. So here's the deal. You cannot cancel cotangent with cotangent. You know why? Because you don't have that. to be able to cancel cotangent with cotangent, you gotta have multiplication going on. You have what? You have addition. That wrecked it, you can't do that, and do you know how many students do that? Tons. You know what a lot of students do? They go like this. That cancels with that. Oh, the answer is 1, I'm done. No, you can't do it. You just can't, okay? Because you gotta have what to cancel? Multiplication. All right, here we go. So what's next?
Work it down.
We're gonna, yep. Are you guys looking?
Yeah.
Cotangent squared and a 1. These are that's a Pythagorean. Look. Go back up top, guys. Look. Go back up. 1 plus cotangent squared is? Yeah. I hope you're seeing this. 1 plus cotangent is cosecant squared. Put cosecant squared in there. So you'd write cosecant squared of theta over cotangent of theta squared, right? Just a minute. You already got it? Work with somebody. It's much easier to do this working with somebody. Okay? Okay, there. I replaced 1 plus cotangent with just cosecant. Now I'm going to ask you, do you like these functions?
No.
No. Get rid of them. What's cosecant? Cosecant squared is just what?
1 over sine.
Yep.
Times 1 over sine.
Now, when you said 1 over sine,
Maybe 1 over sine.
you want to square sine. John, did you hear me?
Well,
Yeah. Okay.
I do it. I extend it out just so I can
Yep.
get rid of this.
What's cotangent squared? I want sine and cosine, guys.
Cosine over.
Say it again.
Cosine over.
Cosine squared over what?
Sine.
Sine squared, okay. All right. So we use the reciprocal function on top, and we use the cotangent identity on the bottom, okay? Now, this is your division bar. That's your division. You are taking a fraction on top, dividing by a fraction on the bottom. And you're not going to do that, right? What are you going to do? Multiply by the reciprocal. 1 over sine squared. Take the numerator and do what? Multiply it by the
Reciprocal.
of the denominator, right?
Yep.
So the denominator would be
I tried.
cosine squared theta over. I did that wrong. I'm done. Hang on. You do what? Sine squared theta over cosine squared theta. Okay. Out with what?
Sine
Times squared of theta.
Sine squares are gone. Your answer becomes 1 over cosine squared of theta. But you can clean it up because we don't want to say our answer's a fraction. That's really just what?
secant squared.
Secant squared of theta. Okay? Now please understand this. There's a couple things that happen here. Molly started us off by saying cotangent with cotangent should cancel. It doesn't because you have what? Addition. Now if you have addition, there's only Pythagorean identities have addition in it. It's this plus this. This is Pythagorean. Go look up there. This was cosecant squared, which I changed over to sine and cosine, and then I worked it out. Okay, here we go. Next up, this one. Okay? Well, I see take this times this and then add this. So to me, if I'm thinking GEMDAs or order of operations, what do I have to do first? Multiply first, add last. So I'm going to take care of these two and then I'll add sine later. All right. What don't you like about these two? Cotangent. Get rid of it. Cosine of theta times what? Plus sine of theta, right? This is cosine over 1 times cosine over sine. Anybody want to say it?
Everything
Cosine times cosine.
Cosine squared.
Cosine squared, good. Over 1 times sine.
5.
Sine. Plus
Sine.
sine.
So the signs can't cancel out.
Okay, okay. Hang on, I'm
Just
getting there.
kidding, sorry.
No, it's a good question. It's just what Molly said.
Sorry.
Molly said it. Cancel this with this, right? Can't. Why? You don't have what in the middle?
Oh, yeah.
Gotta have multiplication. You can't. So this is an addition problem. Addition. What do we need?
Common denominator.
Yes. And what's the common denominator here?
3.
3, because 3 times 1 is 3. Well, yes.
Can you take your
Sine
sine?
times 1 is sine.
Yeah, look at this. Take that number times that number. They both should go into it. What's the common denominator?
Sine of theta.
Sine of theta. If you just multiply your two denominators, it is the common denominator. Okay, do you even have to change this fraction? No, it's already over. Sine, don't change it. This one, you do have to change. Multiply the 1 by what to make it sine?
Sine.
Sine. Sine of theta times 1 is sine of theta. Get up top, do it again. Sine of theta times sine of theta.
Sine squared.
Sine squared. You have two fractions being added together. What do you do to your common denominators? Do you add them?
Combine them.
You just keep
You don't do anything. You just leave them. It's all over what?
sine of theta.
Sine of theta. Okay. Now what do you do with this plus this? Are those like trig identities? Are they the same? You can't take a cosine and add it to a sine. You can't. You just leave it. It's just cosine squared theta plus what? Sine squared theta. Okay? Are you seeing this? Look on top. Look on top, guys. Cosine squared plus sine squared. It has a Pythagorean look to it. Taylor says the top is just 1. Is he right?
No.
Oh, you should look at your identities. Your Pythagorean identity says cosine squared plus sine squared is 1. Yes, it is 1. Taylor, you got that right. Okay? It is 1. But now, clean up that. That's not good enough. We're going to say what? Cosecant of theta is the answer, yeah. That's it. That was a nasty one. Those addition ones are tough. Okay, but there is one more that's not that tough over here. Hang on, it's right here. Slow down. Okay. Okay, this one says tangent squared minus secant squared is what? Some of you might be good enough to just tell me the answer.
Is it 1?
Is it 1? No.
Negative.
Is it what?
Negative.
It is. It is. Hey guys, I want you to take a look at this. We're talking tangent squared minus secant squared. You should be thinking Pythagorean. And so you should go up to the identity up there, tangent secant, and look at it. It says right here, right there. Okay, it says 1 plus tangent squared equals cosecant squared, right? Okay, yours on the bottom says what? Tangent.
Squared minus secant squared.
Okay, so if yours says tangent squared minus secant, couldn't you go this way? Couldn't you go this way and then move the 1 over there?
Yeah.
If you're that good, you could probably say the answer right now is what? Taylor said it. He said -1. But if you can't, then you're going to have to do something like this. Would you guys help me out? I know the bell's going to ring, but would you just help me? What is just tangent squared equal to? What's tangent squared?
Tangent times tangent.
No. Take the formula up above, solve it for tangent right now. I'm listening. I want to know. If you solve that formula for tangent squared, what is it?
Sine squared theta, like cos.
It's
Cosine theta.
it's secant squared theta minus 1. Right? Guys, you know what I'm doing? I'm solving for tangent squared. I put the answer right there. Then I say minus what? Secant squared. Don't cancel, the answer's -1. Oh, you don't walk out of here, Adrian! Stop. Okay.
Already all done.
Alright. Don't get one if you haven't yet.
I might know I got
You didn't get one?
it. I take it.
Yeah, okay.
I know I got this.
John?
I did just.
Hey, Kevin? I got one. Okay.
Adam, hi Christina.
Do you remember that box you
Oh,
a while ago?
this is it. I'm gonna need that homework assignment. That one's for like actual test. I forgot to write. Okay.
Okay, my name is